Hello friends, myself Rahul Thumar working at Dr. Subhash Technical Campus in Electronics and Communication Department. Today we learn the electric field intensity. Electric field intensity. Before that, we conclude the Coulomb's law. We know that in the Coulomb's law, if you have the two charge Q1 and the second charge is Q2, then both will act a force to each other. If both are the positive charge, then the force will be the repulsive, or if the charge are like, means one is the positive and another one is the negative charge, then the force will be the attractive. Now, to find the electric field intensity, we consider the one positive charge Q1. The location of the positive charge one is fixed, and we take the another charge Q, which can be known as the test charge. If we move the charge Qt slowly around the charge Q1, then we note that there will be the force exists everywhere around the charge Q1 on the charge Q2 as per the Coulomb's law, and this force can be given by the Ft is equal to Q1 Qt upon 4 pi epsilon 0 R1t into A1t. Here R1t noted the distance between the fixed charge and the test charge, and the direction of the electric field intensity or the act force is always towards the fixed charge to the test charge, means A1t direction. Okay, now if we consider this force per unit test charge, means Ft divided by Qt, force per unit test charge, then it will be the rewrite Q1 upon 4 pi epsilon 0 R1t square into A1t direction. Here the quantity on the right hand side of the above equation, means the quantity on the right hand side the above equation represent the force which exits from Q1 to the Qt direction. In the vector form we can say that Q1 is the source of the force and Qt at well the force will be the exits, and this force or the radial distance or this direction can be known as the electric field intensity. The unit of electric field intensity is volt per meter. In general, the electric field intensity at point 2 due to the charge Q1 at distance r, means suppose we have this one charge Q which is the test origin, and the another charge is Q which is located on point 2, then as per the formula of the electric field intensity, it is the force per the test charge given by Q upon 4 pi epsilon 0, distance between them is r, then r direction into AR direction. This is the general formula for the electric field intensity at point 2. Okay, we try to solve out the one example of the electric field intensity A. Here we have given that to calculate the electric field intensity E, at point M 1, 4, 2. That means we have the one charge Q here, and we are required to find the electric field intensity at point M, at point M, which is the given 1, minus 4 and 2 for the three different cases. In the first case, we have the given charge Q is the 2 microcoulomb and it is located at 0, 0, 0. So we have the distance between them is R. Suppose charge Q is located at point O, then we can say that distance MO is 1 minus 0 in AX direction plus minus 4 minus 0 in AY direction plus 2 minus 0 in AZ direction. So it will be the AX minus 4 AY plus 2 AZ RMO, and the magnitude of the RMO is under root 1 square minus 4 plus minus 4 square plus 2 square is 1 plus 16 plus 4 means under root 21, which is equal to 5.385. So if we put the value of RMO, so as per the formula we know that Q upon 4 pi epsilon 0 RMO square into AOM direction. So here Q is 2 microcoulomb. So 2 cross 10 raised to minus 6, 4 cross 20 pi 7 cross epsilon 0, value of the epsilon 0 is 8.854 cross 10 raised to minus 12. Value of the RMO is 5.385 square, and the AMO direction means this vector divided by the magnitude of heat. So it is the AX minus 4AY plus 2AZ divided by 5.385. If we try to solve out it, we get electric field intensity E equal to 345.307 in X direction minus 460.409 in Y direction plus 230.204 in a Z direction volt per meter. This is the electric field E at point M due to the charge Q is equal to 2 microcoulomb, which is located at 0, 0, 0. Okay. In the case B, we have given the charge Q2, which is in case B, we have the given charge Q2, which is the 3 microcoulomb at point P is equal to minus 1, 2 and 3. So Here we have the charge Q, which is the 3 microcoulomb, or suppose we say the charge Q2, which is the located at point P2 minus 1, 2 and 3. So, and we require to find the electric field intensity E due to the charge Q2 at point M, 3 minus 4 and 2. So as per the formula, electric field intensity E is the Q upon 4 pi epsilon 0 R square into AR direction. Here R is equal to RP2 minus RM vector minus RP2, because P2 is the force at where it is the origin and the M at where the force is exists, or we can say it is a source. So we can say that RM is 3 minus 1 in AX direction plus minus 4 minus 2 in AY direction plus 2 minus 3 in AZ direction. So we can say that 3 minus 1 means 4 AX, minus 4 minus 2 means minus 6 in AY direction, minus 1 AZ direction, and magnitude of the R vector is under root 4 square minus 6 square minus 4 square plus minus 6 square plus minus 1 square. So we get under root 16 plus 36 plus 1, which is equal to the 7.28, and the value of the unit vector AR, which is equal to the R vector upon magnitude of R, which is the, or we can say that R is equal to magnitude of R upon magnitude of R. So 4AX minus 6 AY minus 1 AZ upon magnitude of R is 7.28. So we get 4 upon 2.AX minus 6 upon 7.28 in AY direction minus 1 upon 7.28 in AZ direction. Now if we put the value of unit vector AR and the value of the magnitude of R in the formula of the electric field intensity E, we can write E is equal to Q upon 4 pi epsilon 0 R square in AR. So Q is 3 cross 10 raised to minus 6 upon 422 by 7. Value of the epsilon 0 is 8.854 cross 10 raised to minus 12 in cross value of the R is 7.28 square into unit vector is 4AX minus 6 AY plus minus 1 AZ upon 7.28. If we solve out it, we get final answer 279.523 AX direction minus 419 in AY direction minus 69.81 in AZ direction volt per meter. Now in the third case we require to find the electric field intensity due to two charge Q1 which is located on the origin and its value is 2 cross 10 raised to minus 6 coulomb, and another charge is Q2 which is located at minus 1, 2, 3, and the value of charge Q2 is 3 microcoulomb. So due to the Q2 charge we already find it here, and due to the Q1 charge we find it in the case number 1. So if we add both the electric field intensity due to the Q1 and Q2, we get the electric field intensity E due to the two charge, means we have to add this one plus due to the electric field intensity Q1 which is the 3.345.37 AX direction minus 460.409 in AY direction plus 230.204 in AZ direction volt per meter. Okay, thank you.